very few of the theorems and postulates. I'm going to do a few of them, but what I am going to review are the skills, because the skills are generally the things that are the most easily forgotten. People don't forget. Well, the more popular theorems, those aren't quickly forgotten. Some of the unpopular ones are forgotten, but people will forget the skills, like some of you did on the test, even though we did 2 review days. Matt, you weren't the only one, Matt. If there was something I was disappointed as a class, it was that so many of you, literally, I gave you a copy of the test, not once, but twice. And you either didn't put it in your notes, or you didn't have it committed to memory, or you were unsure of what to do type thing. There were plenty of you that I saw, you had little algebra mistakes. I mean, I took away very few points for making an algebra mistake because you showed me you knew what you were doing. You just had an algebra mistake. You get an algebra mistake, you don't get to the right answer. But I had too many people, for instance, on the triangle and the trapezoid medians, you couldn't even set the problem up, right? That was kind of disappointing. 2 days of review, and then we'll start chapter 6 next week. So my goal is to always get through chapter 6 by Christmas break. We're going to be easily met. Just so you know, I don't know if I talked about this yesterday, you're going to be taking sometime between now and Christmas, you're going to be taking a test. The test is, it's one of those standardized tests. It's going to be on the computer. If you've been in other school districts, it's that standard test that you take that just basically ascertains what your math knowledge is of everything that you've ever learned in your life type thing. The school's going to start doing it twice a year. We got a late start this year rolling this out, so it's supposed to happen at the beginning of the year and happen at the end of the year. It's a one-day test. I usually make it for a grade in the sense of if I don't, no one takes it seriously. So obviously it's not going to be a grade on how many you got right, but there will be a participation grade of some sort. If you didn't participate, don't try, then obviously you don't get points. Is it going to be over? On? You mean on the? No, literally you're going to walk into my classroom. There's going to be a laptop in front of you. You're going to sit down and take a math test. You get laptop? We have lots of laptops in this place.
I know, but not for you don't have laptops.
Yeah, we have those.
They have a whole cart.
Can I just bring mine?
We have 2 whole cards.
One last year and they didn't give me none.
Can I just bring mine so I can play
Last year we didn't have them. This year we got them this year. They use them in Latin class all the time. Yeah. No, you got to use ours.
I can't play League then.
Okay.
Yeah.
So at the end of this quick review, it's going to take me maybe 15, maybe 20 minutes max. I'll give you the review sheet. It's only 2 pages. It's going to be on chapter 1 and 2 stuff. I would be highly surprised if you don't recall much of this, but we do need to go over the main things. So your goal right now is in your book of truth. In your book of truth, flip through the pages. Make sure this is in your book of truth. So this is going to be a review on everything we did in chapter 1 and chapter 2. Okay. We started off geometry by talking about the most basic thing that we have in geometry, which is a point, right? Remember we said a point is just a location in space, right? It doesn't have any shape to it. Generally, we always use little dots to represent points. We could certainly put triangles if we wanted to, not in geometry, but if we wanted to, we could make it a triangle. Remember, points are named by capital letters, okay? Space is if you took all the possible points that exist, that's what we define as space, okay? Now we do things that you can make from points. If you take 2 points and you play connect the dots, you made a segment, right? So you made a segment. How do we name segments?
Yes.
Which 2 points? It has to be the 2 endpoints. It has to be the 2 endpoints. Granted, there might be a point in the middle. You can't name the whole thing by that point in the middle. Luckily, geometry, I don't have anyone still. I did, chapter 1, have people tell me the name of a line segment with 3 letters. We name line segments with 2 letters, the 2 endpoints. So this is either segment, okay? And what's the symbol for a segment? A line segment over the top of it, okay? So either one defines this line segment right there. Okay? This was, I don't know if you remember when we did this. This is, first week of class. How many different segments are up there? How many different segments are up there? Kara says there's 3, and she is correct. And remember, I think this was literally her question. So you got the small one, you got the medium one, and you got the large one. Okay, so there are 6 different segments up here. Now each segment can, I said 6, 3 different segments up there, but there's 2 ways of naming each segment. Therefore, technically there are 6 named segments up here, but this is the small, this one's the medium one, and this one is the large one. Okay? And the first ugly thing about geometry is that we have 2 different ways of naming and measuring things, right? And this goes for almost everything that we deal with in geometry. There's the way of naming something, and there's a way of measuring something. So Bree, you were not here for this. We name segments when we put a line segment over the top. If we want to measure that segment, don't ask me why we do this. I would have been perfectly okay to put an equal sign after it, but they don't do that. What they do is they take their pencil and they erase the segment over the top and they put an equal sign. Right? If you have the line segment over the top, the only symbol that can come after it is a congruency symbol, no equal sign, right? An equal sign can only be applied if there isn't a line segment over the top. So the only symbol that can apply after the name of it is a congruency symbol. But if you don't have the line segment over the top, you can have an equal. And next chapter, we're going to find out you can put a math gang symbol, right? Greater than, less than. Right? Sorry. Okay, but we'll find that out next chapter. Right. Yeah, and it's kind of gets messy. Like I said, next chapter is a bit challenging. The next shape we dealt with are rays. Rays must start at their endpoints, and they go in bad boy direction forever. Bad boy band direction forever.
Oh, One Direction.
Yeah.
Gosh,
Well,
they're so
One Direction forever.
Yeah.
All right. If there's a mistake, and this is kind of more math teacher, hey, you just did it wrong, but I know you understand the right idea. It's got to start with the end point, and it goes in one direction. The symbol for it is a ray over the top. The symbol will always point to the right, even if the ray points to the left or up or down. But the symbol always points. Once again, that's the name of it. We don't measure rays because rays go on forever, so it has infinite distance. Okay?
Mark us off the arrow the wrong way.
I would, right, at this point. Okay, so here are 2 rays. They both have the same name, X, Y, but they point opposite directions. But notice they have exactly the same name. Notice for the red one, the rays for the symbol and the actual ray point in opposite directions. Okay. All right. An interesting fact is that there's lots of rays here. If we use the endpoint of Z, we have ray ZX, but that would be the same as ZY because remember it just goes to the left wherever. But we have a different ray, XY, as well. So ZY and XY are 2 different rays. One starts at point Z, one starts at point X. If I talk about XZ, though, right, XZ, that kind of goes in the different direction, right? We think about this. Oh, by the way, we have YZ as well, too. If we think about it, these middle 2 actually point, finish the sentence. These 2 middle rays point
In opposite direction.
So guess what we call those 2 rays?
A line.
They make a line. We call them opposite rays. So XY it starts at X and goes to the left. Ray XZ starts at X and goes to the right. Together they do make the entire line, but we call them opposite rays. This is way back chapter 1. By the way, all of you missed this on the test. Back in chapter 1, which is why I put it on the slide. I said we were going to talk much about theorems and postulates, but I will talk about a couple of them. Well, one of the first ones that we used that we were actually able to get a skill from was postulate 2. Postulate 1 was the ruler postulate. Postulate 2 is the segment addition postulate. And it says this: if you have a segment and somewhere in the middle you got another point, what can we say?
If you add up 2 other parts of the whole segment, you can get the whole.
So in other words, you could say
AB plus BC equals AC.
That's all this says. So that if B is somewhere between A and C, then AB, notice I don't have the segment symbol at the top. Now I'm talking about literally a number. It's distance. That the distance of A and B plus the distance of B and C must equal the whole thing. And this is like, it's a duh postulate, like, of course, right? What else would it be? But this was the first one that we actually got a skill from. In other words, I could actually ask you a question with numbers and you had to do some math, which is why this is the one I've chosen for us to practice. So what it says visually is this piece plus this piece equals the whole darn thing. Okay, that was called the segment addition postulate. So I could give you a question like this. Bailey, how big is RS? How big is the whole piece? Look at the diagram. The whole piece, meaning RT. How long is RT? By the diagram, it's 17. What other piece of information are you given up there? So therefore, RS must be, there's your first skill, right? If you want to be ugly and write it mathematically, you would write what Seth just said, that the small piece plus the medium piece equals the big piece, RS plus ST. We plug in the numbers. If you needed to do a little bit of algebra, you do a little bit of algebra. Subtract 12 from both sides, and you find out that RS is 5. Okay? That's as easy as it gets, but we can certainly make it more complicated by adding variables or another point.
Oh,
Right? So if I add another point, now I got 2 points in between. I can make it a bit more challenging, right? Certainly if I add variables as well too. The only time I can add variables if it was a midpoint, because I don't know what the relationship is unless it's a midpoint. Okay.
oh yeah, yeah.
Okay, so this one's a bit more challenging, right? First off, you got to see what it's asking. It's saying EG, so from E to G. So basically, I'm missing the point from F to G, right? So if I were asked to figure this out, we know that the whole thing, EG, would be equal to this part, EF plus FG. Well, I already know part of that. Which part do I know? Of this, what part do I know? Which is how long? Which is 5. So I know that EF is 5. Therefore, the question is, how long is FG? Well, what are we given? We're given from the point from D to F is how long? From D to F is how long? From, I'm going to ask it again. From D to F is how long? 9. I'm only getting Seth is the only one to answer my question here. We know the whole thing is, so Danny, how long is FG? Say again? Well, I want you to take what the previous people just said. What did they say? I know, because you weren't listening. So listen this time, please. The whole piece is how big? Okay? And we know that this piece from D to F is, so how big is FG? And you get 8. Okay? Now, why is that important? Because that's how we're going to get to EG. We already knew that EF, Garris told us, was 5. Danny just told us that FG was 8, and 5 plus 8 is 13. So I can make this more challenging by putting more points in the middle. Okay? So that was our first skill from chapter 1, segment addition postulate. Okay. Moving on, right? What am I about to review? Okay. Y are made from
Rays.
2 rays that share a
Vertex.
So 2 rays that share a vertex make an angle. That's the definition of angle, right? It's a figure shape formed by 2 rays with a common endpoint. Okay, 2 rays put together. There were 4 ways, and this, if there's a skill from chapter 1 that you are poor at, it's this one. Some of you still can't tell me the name of an angle. Okay, Danny, you're one of them, right? we have to be able to name angles, which is another reason why I want to do this review today. We have to be able to name angles. There's 4 ways of naming an angle. Angles, first off, it's called the long method, right? We don't start at the vertex. We start at any other point along one of the rays. And we go from that point, we stay on the black line, to the vertex, to the other points. So this is either angle ABC or, say, so the people that already got this in chapter 1 are still getting it now. I'm just going to claim there's at least 3 of you out here. You can't tell me the names of angles. Every test I give you, when I say name the angle or do something with the angle, you go to the wrong angle. Connor, you struggle with this as well too, right? You have to start here if you're going to call it the long method, right? You have to start not at the vertex, but you got to start on one of this, and you got to stay on the black line. And all you do, and I told you from chapter 1, trace the angle with your pencil, your finger, whatever. Okay? So this is ABC or CAB. What are the other 2 ways of naming this angle? If, and I'll just say this, 8 of you out of the 18 couldn't do this on the test that we took yesterday, right? If you're, well, I can't do it because they haven't taken their test, right? One of the angles, right, on the test looked like this. And I forget what I'm just going to say was A. Guess what you called this angle right here? 8 of you. Guess what you called that angle right there? Guess what you gave its name? Take a guess. Somebody. You called it A. Why can't you call this angle A? Well, there's a point right here. Bree?
I don't know.
It is wrong. Yet 8 of you did this. Chris, you did it as well too, even though you got the proof right. You called this angle right here A. Why is it not angle A?
To be fair, I was doing the lines necessary.
I'm still waiting for an answer. Why is this not angle A?
Because there's already.
Because there's 4 angles here. What does A mean?
Midpoint was A.
Right. If you want to name this angle right here, guess what you got to have? Two options. You either have to have a number, maybe there's a number 1, now you can call it angle 1, or you have to have 2 other points. You better have a B and a C. Now that angle right there is angle CB or BAC.
That's right.
Right.
Angle cap.
No, you called that angle A. You called that angle A. And I'm like, which one is he talking about? I don't
I
know.
was referring to the midpoint.
Right,
I
but
thought the midpoint was A.
I'll show you on your test when I hand it back tomorrow. All right. So please start calling your angles the correct way. All right. We're in chapter 6, and some of you are still not mastering chapter 1 stuff. The other 2 ways are you name it if it's floating there all by itself. There's no way you can confuse it with anything else. If you got anything that goes through B, you can't call it angle B. But if it's just this angle all by itself, you can certainly call it angle B. Or if it's got that number, you guys do fine with the numbers, angle 1. Okay? All right. And geometry, the same thing with segments. We have a way of naming things, and we have a way of measuring things. Right? If we're naming angles, what's the name of that angle? Okay? If we're measuring that angle, how do we write it? Okay? The name of it is angle B. If we're asking how big is the angle or we're measuring it, we put that little M. The little M means measure. I haven't seen anyone make a mistake on this too often, but I just know it's because many of you on your proofs, you don't even try when you're trying to literally say, hey, the measure of angle 1 plus the measure of angle 2 is 180, right? That's usually when I'll see this mistake. Make sure that if you're saying it's angle measurement, then you're putting the little M there, okay? All right. Adjacent angles, another thing that we're still pretty weak on. Like if I ask you to name the adjacent angles, you're unsure of what that means. Adjacent angle means 2 angles that are next to each other and they share a common side array and a common vertex, right? So FEG, this angle right here, I'm going to trace FEG. This angle right here and this angle right here, which is HEG, right? They share a common vertex and a side. The no interior points is this. If you pick any point inside this angle, it's not in this angle. Like, well, how could it ever be? Well, remember, if they were right, I'll give you two angles that share a vertex, right? Here are two angles. This angle here, I should do them in different colors. I'll make them dark and white. Those two angles right there share a common vertex. They don't share a common side. So if I go inside of the dark one right here, this point right here is inside of both angles. It's inside the dark one and the light one, right? So these are not adjacent. Where these, any point inside here is not in the other one, they're adjacent. All right, we talk about adjacent angles in pre-algebra, we just don't add that more fine point about points in the interior. All right, guess what I'm about to draw you a picture of now? What kind of angles am I making? Matt, or not Matt, Chandler, wake up. What am I making? Yeah, sort of, but no. Angle bisector. It's the idea of a midpoint, right? So if you have an initial angle and you cut it in half, you cut it in half with a different ray, right? You make two congruent angles. We call that a angle bisector. Okay? You guys are okay with this idea right here. All right, and then we come to the next one that we get a skill from. It's called Postulate 4. Remember, Postulate 3 was the protractor postulate. The Postulate 4 is the angle addition postulate. And it basically says the same thing as a segment addition postulate. It just applies to angles. It says, somebody finish it.
If you add up angle AOB and angle COB, since ray OB is a bisecting angle.
No, we don't know it's bisecting.
Well,
I like the way you started it. Okay. If you add up COB plus AOB, you get, that's what it says. It says the big angle is equal to all of its individual parts added up together. Okay, so AOB plus COB equals the whole darn thing. And we get the skill from that is I can start plugging in numbers and do things. Angle, or I should say adjacent angles, we also get some special ones. Here's your first special one. What am I going to say about this angle plus this angle? Equal 180 because they make a line. We call them a linear pair. A pair of angles that make a line. So we know that COB plus AOB would equal 180. We've used that plenty of times. So here's your first skill. Some of you get hung up on this. Like, I know you know what to do, and my encouragement to you is to slow down and label everything. There's a lot of stuff up there. It's actually a pretty simple one to do. And if you would take the time to do it carefully, you'd get this one right every single time. Okay? A lot of times I like to start with the question. It's asking me to find EUV. Once again, I take my pen. I'm going to mark EUV. I'm trying to find that angle right there. Well, by the angle addition postulate, I know that this plus this equals this plus this would equal, well, would equal the whole thing, which he's already read, that it says that TUV equals 162. So if I were to set this up algebraically, it would be the piece that I'm trying to find, EUV, plus this piece equals the whole thing. That says that TUV is 162. Any other bit of information up there? And TUV, which would be, TUE, which would be this one, is 120. So if we're to plug the numbers in, it's just a quick algebra problem. Do a little bit of algebra, we get to the answer. So there's our second skill, the skill by me, like we can do problems with this. Okay? So that was all chapter 1. Chapter 2, quick review. This will be quicker. We dealt with special angles. The first one was complementary. You dealt with this since 6th or 7th grade. Remember, complementary is 90. Finish the sentence. Complementary is 90, comma. Complementary is 90. What's the next thing I'm going to say? Supplementary is 180. Supplementary is 180.
I said that.
I didn't hear you. If I would have, I would have. Complementary is 90. Supplementary is 180. For those of you who have problems remembering that, remember, if you put them alphabetically, complementary comes before supplementary. 90 comes before 180. Okay? These two angles here, this triangle, are complementary. Supplementary is your 180. Generally, if something's supplementary, right, it's making lines, right? The two angles don't need to be next to each other, but in this case they are. They're supplementary. So for instance, our chapter we just dealt with, you know that a parallelogram, that angles that are next to each other on the interior of any parallelogram are supplementary. That's this one and this one, or this one and this one. A few of you missed this one on the test. Okay? All right, guess what I'm going to show you now, Karis? Look at the picture and take a guess. Vertical angles, very good. So vertical angles, you're in geometry, I can't tell you how many times your eyeball is looking for that X. If you see an X, you got vertical angles. Remember, I said the vertical angles should probably be called, anybody remember? I think they should be called opposite angles. Why? Because it's really the angles that are formed by an X that are opposite each other that are the ones that are vertical. Yeah, 1 and 3 absolutely look like they're vertical. 2 and 4 look like they're horizontal from each other. So I personally would rather somebody put opposite, but they didn't listen to me. Okay, so vertical angles. What's the so what about vertical angles? Vertical angles are congruent. So be careful with vertical angles. Get it? Right. This is the classic one. Nobody makes the mistake. Yet if I draw it like, everyone makes a mistake. So how do you identify, Bailey, vertical angles on that big ugly mess right there? Hey, what's vertical to 3? Well, I don't know, right? So how do you find it when it's this? You're not going to mess this one up. That's vertical to that. That's what about this ugly mess? What are you going to do? You're going to take your pen. I said what's vertical to 3, and you're going to continue the two rays that make angle 3. So if I continue this one, I'm going like that, and I'm going like this. And we can clearly see, Bailey probably can't see it, that angle would be its vertical pair. Okay? Make sense? I still don't see this on some tests. Like you guys will be doing something, you'll see it's vertical, it'll be that ugly mess right there, and I should see marks on your test, and that's the way I know for sure you're identifying the right angle. Okay? Vertical angles are congruent. All right. So we can play this trick right here. They give you this big mess right here, and they give you 1 or maybe 2 of the angles. All right. Bailey, what's the first thing we have? Sorry, which one? Which is the first bit of information you see up there? So a good idea, therefore, would be to do what to our picture? It says that measure angle 1 is 30. A good idea now would be to, can't hear what you said.
I don't know.
Label it, right? So where am I going to put 30? Okay. Why is that a good idea? From the previous slide. Do you see an X? So from the previous slide, what should I do now? I mean, literally what you just did on the last one. Let's take our pen and let's make that X. Because eyeballing this, I don't know if that's angle 3, 4, or 5. Don't eyeball it, draw it. If I draw it, I can immediately see, well, you might be able to see, but the angle that's vertical to angle 1 is, can you see it? Therefore, what am I going to do? I'm going to write down that 4 is vertical, it's got to be 30. Okay. What do you think, Connor? What would be my next step? She did that, she labeled it, and she found out its vertical pair is 4. Now what? Look at the whole problem. What would be logically the next step? We just took care of this one. It's not a good day. Got something for me, Colin? Did we use all the given information? What didn't we use? So same thing I asked Bailey, what would be a good logical next step? Let's throw that measurement in. Let's label 6. Let me catch up. 6 is 110. Finish it. Take your pen. Here's the 6. Maybe, okay, well, you guys probably don't have erasers, so that makes it a little bit more challenging. All I'm going to do is I'm going to extend those lines to find out what its pair is. What's its pair? And that's what I would do. So I now know that 3 is also 110. Okay. Cadence. That's still a big mess up there. I'm still missing 2, 3, and 5. What do you think?
Isn't there equal?
Oh, I'm sorry. So we were only missing what? We were missing 2 and 5. What do you think?
Should we like subtract those 2 or something?
Subtracting from? Subtracted from? You said it, but say it again. Subtracted from? Why 180? Okay, this is where that you're looking at this straight line right here. I got that straight line. If I cover up the rest of the mess, it's easier to see. So sometimes just covering things up with your hand, your pencil, paper, you can see that 1, 6, and 2 make a straight line. So do it in your head real quick. 40, okay? So therefore, supplementary, we do that math right there. We find out that it's 40, therefore 5 is. This is a skill that all of you should be able to do. This is chapter 2, by the way. All right? And we got all this information from 2 basic ideas. 1, vertical angles are congruent, and 2, angles that form a line, they are supplementary. Okay. So around the room real quick. Matt, first one. How big is B? You can either tell me what to do or you can tell me the answer.
So since it is 55 and it's a right angle, take 90
Because they're complementary. Anybody can do that math in your head real quick?
35.
35. Why did I write that?
42.
I don't know. Maybe I should review my slides better. Okay, these are not the droids you're looking for. Well, that math is true, but it doesn't apply to that picture.
No.
All right. Danny, look at this picture right here. Oh, I hope I got this one right. Either tell me the answer or tell me what to do. Not a right angle. You just try to look at it and see if you see a shape that's formed with the 2 angles. I see no triangles, but if I take my hand and I go like that, those 2 angles make a, how many degrees in a line? Therefore, mathematically, what do you need to do to get to the answer? Subtract that one. Did I do it right? Oh, thank God. All right. So whatever that answer is, that's the answer. Yes? All right. What do you got? Last one.
Would it just be 88?
Why would it just be 88?
I don't know, because they look congruent.
Because they look congruent? No, we can't do that in geometry.
So then when we subtract 180, no. Well, yeah, would we just subtract 88 from 180 then?
Where do you see a line? I see a line
Well, it's
right
'cause
here,
it was-
absolutely.
it's 'cause it
So
was
if we were to find
triangles.
this angle right here, absolutely, subtract it from 180. So I can find this one by subtracting from 180.
And then-
Karis is saying you don't see the obvious.
Okay, then she can solve it.
No,
Yes.
you got it. By the way, you could do it the way you're doing it. 180 minus 88 would be what? 92? All right, so this one is 92. Okay, now what? In geometry, your eyeball should always look for.
Oh. Yeah, I see the X.
So what is it? Why am I showing you an X then? What's so special about an X?
I don't know.
Where do I got to go back?
Okay, probably.
It wasn't. I thought it was. Did I already go past it? I need a special button. It was the next one, and I went by that fast. Why am I showing you that picture? It's the same picture. That's the picture. They tell you that 3 is, what was it, 88?
Yes.
And they're asking how big is 1?
I said 88.
Because
Opposite sides are congruent.
we would say vertical, but yes, I agreed that. That's the picture, right? That is the picture. But I'm just going to point out your initial thought is that it was 92. Well, guess what? Now take my hand, cover that out. Guess what's the relationship between 92 and angle B? They make a.
What?
They make a.
Writing?
It looks close.
No, they make a straight line.
They make a straight line. So we could do it one more time. You could do 180 minus 92, and you get 88. By the way, that's how we proved that vertical angles were congruent, was exactly what he just did right there. We showed that vertical angles were congruent because 2 angles form a straight line. Subtract from 180. Subtract from 180, you get the same answer. Okay? Questions? I think that was it. That was it. All right, so that's chapter 1. Chapter 2, quick review. I said it would take about 20 minutes, and I lied. It took 25 minutes. What you guys have is you have a review worksheet for the remainder of class. Hey, once again, I mean, the way you get through geometry is you just pay attention, right? You pay attention, you understand the skills, you're guaranteed to get a C. I'm just glad there's no one here that can't get a C in the class. If you choose not to pay attention, not to try, you absolutely can fail, absolutely. But it's a choice you're making. I didn't say you can make an A, but I did say you can make a C. You can pass this class if you try. But you got to try. Try means that you're listening class. If doodling is your thing, Danny, if doodling is your thing, and I don't see your eyeballs going up to the board constantly, then you're not paying attention. You're just doodling, right? Geometry is a visual math. You know, algebra is a calculation-based math. Geometry is a visual math. The eyeballs have to go to the board constantly, right? If I see you doing your homework, right, well, then clearly I understand what's going on. You've already figured it out. You're doing your homework. But too often in this class, I'm seeing people like, you're just not paying attention. This is a choice you're making to not pay attention. So my suggestion for the rest of the year is to at least pay enough attention that you can do your homework. You want to get started on your homework during class, I've never said no to that, right? But you do have to pay attention. All right. Since this is the first year I got you, you haven't heard all my speeches, 40 different times. Why do I put the answers on the back of a review sheet? Yeah, but what's the purpose of that? Okay, what's the larger goal there? So not only you know that you're wrong, it's so you can ask for help. I got most of those wrong, right? That's the starting point of a conversation with the math teacher, or maybe the person sitting next to you, as long as it's a math conversation. You're never gonna hear me ever say, hey, shut up. Well, why are you talking to the person next to you if I hear a math conversation going on? But the purpose of the answers is so that you can confirm your mastery of it, help you understand what you got wrong, but really what it is it's to identify the things that I got no clue. I'm not even sure how to do this. With the few exceptions in this class, none of you have ever asked me a question. None of you, right? It's me going into student advisement and forcing questions. You got this? It's like I'm pulling you hard to even have you ask a question. None of you have showed up for tutoring ever. Jenna one time, right? Danny showed up a couple times, but it was because he failed a test, and kind of the parents are like, hey, you're going to tutoring, you don't have a choice, right? That's what 7th graders do. My mom said I got to go to tutoring, right? As high school students or college students, you guys have heard about office hours before? You heard that word before, office hours?
Yeah.
So college professors, they do the same thing as high school teachers, right? They do tutoring, except they give it a fancier name. They call it office hours, right? If you're in a course and you're struggling at something, you look up on the syllabus and it says, you know, my office hours are from 3 to 5 every single day. And then your happy butt goes and sees your professor and you say, I don't get this stuff. My office hours are student advisement or Monday through Thursday after school. Many of you are passing this class and you don't need any speeches from me because you're doing fine. Some of you are like, you're doing poorly and you're like, I'm perfectly okay with this. That's not the school that we're in. That's not what you want for yourself. Be successful in the course. Take advantage of all the opportunities you can to do better. None of you should be challenged by what I just put in front of your face. It's just, like I said, none of you should be challenged. Except for us. You can't. But the point there is, you know, hey, I don't need you to ask me questions if you have it, right? But I do need you to ask me questions when you don't get it. And every test, some of you show me that you don't get it. How did we get to test day to find out that you don't get it? You should be answering that question every day when you're doing your homework. Oh, I don't get this, right? Or I got this. Even when you come to class and you get, you know, majority of the answers wrong, but you ask a question the next day when I'm going over homework, you're like, well, I got most of those wrong. Oh, now I see what I'm doing wrong. That's the learning process. That's not the, I'm a bad student because I got my homework wrong. That's I'm a good student because I came back the next day and I asked questions and I figured out what I was doing wrong. Is that enough of a speech? That's not. Okay. Remember, and we just did parent-teacher conference, and you know, I say it during parent-teacher conference. You can take a retake on any quiz or test. Any quiz or test. If you get a B or an A, I'm not going to give you a retake. But you get a C, D, or F, absolutely. Right? You can change your grade. You don't have to be satisfied with a low grade, especially if it's on stuff that you understand. Proofs are always going to be challenging. Proofs are just to separate the B's from the A's. But all the skill stuff, what's in front of your face right now, this is chapter 1, chapter 2 stuff. But all that stuff, you should kill it all. Every single test. Most of you did okay on the test. Why do I have so many? I have 4 other students I need to hand this to. I've written off 2 minutes, too much stuff. We good? Everybody tracking? Karis, why don't I see your pencil moving? By the way, this is all review stuff. There's nothing here. And I couldn't have showed you this on day 1 of geometry, but by chapter 6, you guys are like, this is not even a challenge to you. Yeah.
Is this like a test review? We only do as
No, you got to do the whole thing.
many.
Whole thing. There's only 24 questions.
24 more questions than I thought.
What number are you on? You're all halfway through, sort of. One question away from being halfway through. And I gave it to you less than 10 minutes ago. And I forgot to take roll again. All right, e-learners, any questions? Nothing? All right, I will let you guys go. We're going to do another review, chapter 3 and 4 tomorrow. That'll be Friday's work and homework, and then we'll pick up new stuff, chapter 6 on Monday.